For years, it just coughed. A gentle puff of steam now and then, a quiet tremor deep in the earth. It was a landmark, a sleeping giant on the skyline, its breath a soft white cloud against the blue. It was predictable. It was, well, we thought it was safe. But then, it didn't just cough, it roared. A seemingly quiet giant has awakened, and it's shifted from a harmless little cough to a full-blown, explosive eruption. We'll show you the dramatic footage and break down the terrifying science of why this sleeping volcano is now a deadly threat. This isn't just a mountain letting off some steam. This is a cataclysm, and it reveals a powerful truth about the planet we all call home. Taal Volcano stopped coughing is now exploding. For generations, the volcano was a silent neighbor. Communities grew up in its shadow. Farmers worked the rich soil on its slopes, and tourists snapped photos of its majestic, slumbering frame. Its periodic coughs, those small releases of gas and steam, were just part of the local scenery, something volcanologists saw as a sign of a breathing, but stable, system. These were just the slow, steady release of pressure from deep inside the earth, a process that can go on for centuries without any trouble. But here's the thing, that state of dormancy is one of the most deceptive tricks in the natural world. A volcano that's constantly spewing lava? We get it, it's obviously dangerous. But a dormant giant, one that's been quiet for hundreds or even thousands of years, can lull us into a false sense of security. We've seen this happen time and again. Look at the Reykjanes Peninsula in Iceland. After sitting quietly for nearly 800 years, it dramatically reawakened in 2021 and has been erupting relentlessly ever since. This pattern is a reminder that dormant doesn't mean dead. Around the globe, giants are waiting. Japan's Mount Fuji hasn't had a major eruption since 1707, but it's still classified as active. Here in the United States, Mount Rainier looms over major cities, a beautiful but threatening presence. These mountains are just waiting. The quiet breaths, those subtle coughs, are just symptoms of a colossal power being held in check. And for the people living nearby, the question was never if it would wake up, but when. They just never imagined it would be like this. The change wasn't gradual. It was a violent, instantaneous rupture. The years of quiet ended not with a warning, but with a detonation. The ground heaved. The peak, a familiar shape against the sky, was suddenly gone, replaced by a column of fire and ash. This is the moment the giant stops breathing and starts to scream. This isn't a gentle flow of lava like you see in Hawaii. This is an explosion, and it's what happens when centuries of unimaginable pressure are finally unleashed. The blast sends a shockwave tearing through the air, a sound so profound you feel it in your bones. The molten rock, superheated to over 1,000 degrees Celsius, isn't pouring out. It's being violently shattered and thrown. It becomes a pyroclastic flow, a ground-hugging avalanche of hot ash, pumice, and volcanic gas moving at hundreds of kilometers per hour. These flows are inescapable, incinerating everything in their path. At the same time, a column of ash and pulverized rock is blasted tens of thousands of feet into the atmosphere. And inside that chaos, something both terrifying and beautiful happens: volcanic lightning. The constant friction between millions of tiny ash particles generates immense static electricity, creating a furious, crackling network of lightning inside the plume itself. From the ground, it's pure chaos. Fissures can rip open the earth, creating curtains of fire. Boulders the size of cars get launched for miles. And the sky turns dark as the ash cloud blots out the sun, plunging day into an eerie, suffocating twilight. The world is transformed into a gray, landscape. This is no longer a mountain. It has become a wound in the earth, bleeding fire and fury. So how does a mountain go from a few gentle puffs of steam to a cataclysmic explosion? The answer is a hidden battle happening miles beneath our feet, inside the volcano's magma chamber. For centuries, that chamber was pretty stable. It held older, cooler, and stickier magma. This effusive magma let its gases escape slowly, which created the harmless coughing on the surface. Think of it like a bottle of soda that's been left open. The fizz just slowly escapes. But then, something changes. A fresh batch of magma from deep within the Earth's mantle muscles its way into the chamber. This is called magma recharge. This new stuff is hotter, runnier, and supercharged with dissolved gases like water vapor and carbon dioxide. It's like injecting a can of vigorously shaken hot soda into that already open bottle. The arrival of this hot, gassy magma throws the whole system into chaos. It heats up the old, sticky magma, but it also pumps a massive amount of gas into a chamber that can no longer handle the pressure. And that's where the second key ingredient comes in: viscosity. The existing magma is often high in silica, which makes it incredibly thick and sticky. This viscous goo traps the new gases, stopping them from escaping peacefully. The chamber basically turns into a subterranean pressure cooker. As the magma rises and the surrounding pressure drops, those trapped gases start to expand violently, desperate to get out. Sometimes, a physical barrier helps set the stage for the big show. A plug of cooled, hardened magma can form in the volcano's throat, acting like a cork in a champagne bottle. Behind it, the gas pressure from the churning magma builds to an insane level. Eventually, something has to give. The rock above the magma chamber, or the plug in the conduit, can't take the force anymore. It shatters. The result is fragmentation. The magma is literally blown to bits into ash and pumice by the explosive expansion of its own gases. The energy released is staggering, and it's what drives the terrifying eruption we see on the surface. That violent shift from a quiet cough to a deafening roar is the volcano's final, desperate gasp. In the face of that kind of power, the human scale seems impossibly small. But it's here, in the shadow of the roaring giant, that two very different human stories unfold. One of survival and one of science. For the people who called this place home, life is changed in an instant. The eruption kicks off a frantic race against time. Evacuations are ordered, but the explosion's speed can catch many off guard. The main threat often isn't lava, but the ash. It falls in a thick, heavy blanket that can collapse buildings under its weight. It contaminates water, smothers crops, and turns into a slippery, hazardous sludge with a bit of rain. Even the air becomes dangerous. Volcanic ash isn't soft like soot. It's made of tiny, jagged particles of rock and glass. When inhaled, it can cause serious respiratory problems, especially for kids, the elderly, and anyone with asthma. On top of that, gases like sulfur dioxide mix into the air, irritating the eyes and lungs, making every breath a gamble. But at the same time, another group of people rushes towards the danger: the scientists. For volcanologists, an eruption is both a crisis and a priceless opportunity. They scramble to deploy an arsenal of instruments to figure out what's happening inside the beast. Seismometers track the earthquakes that signal moving magma. GPS stations and satellites measure the ground as it swells or deflates with the changing pressure. Drones and specialized planes fly daring missions, sometimes right into the ash plume, to sniff the volcanic gases for clues about the magma below. This science saves lives. The successful forecast of the Mount Pinatubo eruption in 1991, based on this kind of monitoring, saved tens of thousands of people. Every piece of data, every rock sample, helps build a better picture of the volcano's personality. These scientists aren't just studying rocks, they're reading the pulse of a living mountain, trying to translate its language to protect everyone in its path. From a quiet, coughing giant to an explosive, world-altering force, this volcano's journey is a dramatic lesson in the power of our planet. It shows us that a dormant status isn't a promise of safety. It's just a pause, a long, slow breath before a potential roar. The science reveals a violent, hidden process, a battle of pressure, temperature, and chemistry that can hit its breaking point with terrifying speed. Recent reawakenings in places like Iceland and the Philippines, where Taal Volcano has had multiple minor eruptions in late 2025, are a global wake-up call. There are around 2,500 potentially active volcanoes worldwide, many of them snoozing right next to populated areas. We can't stop them, we can't contain them, but we can listen to them. Organizations like the U.S. Geological Survey and volcano observatories across the globe are dedicated to doing just that, using science to turn the Earth's whispers into warnings we can act on. Because in the end, these giants speak a language of immense power. The coughs are a conversation. The roars are a final, non-negotiable decree. It's on us to listen, to understand, and to respect that power before the coughing stops and the world is forced to listen to the explosion. If you're fascinated by the raw power that shapes our world, make sure you subscribe and hit the notification bell for more deep dives into incredible natural phenomena. And to see what happens when a volcano doesn't just explode, but threatens to collapse an entire island, check out our next video on the Cumbre Vieja eruption. Thanks for watching.